Let us look at another very interesting exercise. We have to find Pythagorean triplets. And I'm sure you know what are Pythagorean triplets. These are numbers, three numbers, such that the sum of the squares on any two of them is equal to the square on the third number. And again, I'm sure you know this is famously related to a right angled triangle, where C will be the length of the hypotenuse and A and B are the lengths of the other two sides. Now, how do we find such numbers? So what Euclid does is in proposition 10.29 lemma 1, he explains how to find this. And what he concludes is that if we use this formula, of course, he doesn't say formula, but he arrives at this way of identifying these numbers. Here, AC and DF are two numbers such that they are both either odd or they are both even. That means they are of the same parity. Why? Because if AC and DF are not both even, or if they are not both odd, then the difference between them would not be a whole number. We'll get into fractions. Say, for example, if I say 2, so 3 square minus 2 square. So 9 minus 4 is 5. 5 by 2, we get into decimals. Similarly here, 5 plus 4 is 9 by 2. We get into decimals. Whereas if we have both these two as either even or odd, then they will be even. So here 3 minus 1 will be even, and even minus even will also be even. Odd minus odd will also be even. Now here, with these two values, 3 and 1, what are we getting? Now, from where did this 3 come? AC times DF. 3 times 1 is 3. 3 square is 9. Minus 1 square is 1. 9 minus 1 is 8. 8 divided by 2 is 4. Similarly here, 3 square is 9. Plus 1, 10 divided by 2 is 5. And this is our famous Pythagorean triplet. A right triangle with sides 3, 4 and 5. So here, let's say AC times DF square is equal to A square. AC square minus DF square by 2 square is equal to B square. And AC square plus DF square by 2 is equal to C square. Then we can write this as A square plus B square equal to C square. The way Euclid is uses this is by saying C square is greater than A square by B square, or C square is greater than B square by A square. Book 10 of Euclid's Elements is full of this statement. Okay, but what happens if we don't want a Pythagorean triplet? We want square on A plus square on B not equal to the square on C. But here A, B and C should be whole numbers. So pretty straightforward. Just subtract 1 from this AC square minus DF square by 2 minus 1 the whole square. And based on these numbers, what do we get? We get 3 square plus 3 square is not equal to 5 square. Purely applying this formula. Because here AC is 3, so 3 square. Now here AC square minus DF square. AC square is 9 minus 1 is 8 by 2 is 4. 4 minus 1 is 3. It's strictly true, but we want two different numbers, then of course we will have to change this. So here in this example where AC is equal to 5 and DF equal to 1, we have 5 square plus 12 square is equal to 13 square. So 5, 12 and 13 are the Pythagorean triplets. And these are three numbers which do not follow the Pythagorean formula. So we have 5 square plus 11 square is not equal to 13 square. We have AC equal to 5, DF equal to 1. So we have two other options for DF. We can make DF as 3, then this becomes 15 square plus 8 square equal to 17 square. Again, making these two equal doesn't make sense because the difference will become 0. And making DF greater than BC also doesn't make sense because the difference goes into negative. Remember, magnitudes cannot be negative. So we have to keep AC greater than DF. Similarly, if we make this as 7, then again we start with 1 as DF. So we get 7, 24, 25, 3, 21, 20, 29, 35, 12, 37. Again, if you want some more, just start with 1 again. So AC is 9, DF is 1. So 9 square, 40 square, 41 square, 27 square, 36 square, 45 square. Now here, if you noticed, I kept on using only odd numbers. Let's take even numbers. Let's say this is 2. AC should be greater than DF. So let's make it 4 so that both are even. So now we get 8 square plus 6 square is equal to 10 square. Let's increase this to 6 so that we start with 2. We get 12 square plus 16 square equal to 20 square. If we increase it to 4, we get 24 square plus 10 square equal to 26 square. And you can verify it. So here let's take a bigger number. This is 12. So DF should also be even. So let's take the highest possible value here. So we have 120 square plus 22 square is equal to 122 square. Remember, Euclid was working only with whole numbers. But here, because of this software that we are using, we could also go in between numbers. But Pythagorean triplets, when we say, we are talking only of whole numbers. That was very interesting, right? So that's it for now.